Everyone. Our first lesson for this week is to solve quadratics by taking the square root. So you will need your square roots note sheet, which is already posted on Google Classroom with this Edpuzzle, and you will want a pen or a pencil and your calculator. Okay, so our main goal for this video is to solve quadratics by taking square roots. We are actually not going to solve by completing the square just yet. That'll be the next video. Okay, so here's an example, and it is 2x squared minus 98 equals 0. And that's not a trinomial like we've seen before, so we can't factor it, and it's not a difference of two squares. So here's how you're actually going to solve this. And basically, the first step is you want to isolate the x squared. So what they do in order to do that is step 1, they add the 98 over, or add 98 to both sides. So then it's 2x squared equals 98. Then step 2, they go ahead and divide both sides by the 2 to get the x squared by itself. And they simplify in step 3 here. So 98 divided by 2 is 49. Then in step 4, they're left with x squared equals 49. And so they go ahead and take the square root of both sides, and they simplify. And here's something important to notice here. So step 5, when they simplify, they write it as x equals plus or minus 7. So if you look at this math tip over here, it says when taking the square root of both sides of an equation, include both positive and negative roots. For example, x squared equals 4. If you went to take the square root of 4, you would write that as plus or minus 2, so the positive or the negative version. And we know that's because if you were to square negative 2, and you can even do this in your calculator, but negative 2 squared is equal to 4, just like positive 2 squared is equal to 4. So that's why when we solve by taking the square root, we include the plus or minus in the answer, because it could be positive 2 or it could be negative 2 that would get you that answer of 4. Okay, so let's go ahead and try a couple. So in this first one, again, we want to isolate the x squared. So I would go ahead and add the 25 over. And then I'm left with x squared equals 25. And now my x squared is isolated, so I would go ahead and take the square root of both sides. And square root of x squared is x. And the square root of 25, I am going to write as plus or minus 5. And that's it. There's your answer. Okay. All right. Then let's move on to part B. So in part B, I would first add over the 49. And I'm left with 9x squared equals 49. Then I would, x squared is not by itself yet, so I would divide by 9. And now I'm not going to go ahead and cancel anything out or simplify this just yet, because I can see that x squared equals 49 over 9. I can see that 49 and 9 are both perfect squares. So when I go to square root, this is going to work out pretty nice. Okay, so I go ahead and I square root both sides. And when I square root the second side, you can also think of it as it's technically like square rooting the numerator and square rooting the denominator. So that's going to look like x equals plus or minus, and the square root of 49 is 7, and the square root of 9 is 3. So that's going to be plus or minus 7/3 as your final answer. Okay. So that's why we didn't simplify earlier, because both of those 49 and 9 were perfect squares. Okay, let's keep moving here. In this next one, again, we're going to start by adding the 7 over. So you get 25x squared equals 7. Then we go ahead and divide by the 25. So same steps as the last one. We're just trying to isolate the x squared. And we're left with x squared equals 7 over 25. Again, I can tell that that 25 is going to be a perfect square. So I'm not going to do any simplifying here. I'm just going to take the square root of both sides. And remember, that's like taking the square root of the top and the bottom separately. So square root of x squared, we're left with x equals square root of 7, we don't know. Square root of 7 is not a perfect square, so we're going to leave that as written under the radical. Okay, and just like what we talked about in class, we cannot simplify that radical at all, so we're just going to leave it as square root 7. And then square root of 25 is 5. Whoops, and see, I even forgot my sign. I didn't leave room for it, so let me rewrite that. Plus or minus square root 7. And then square root of 25 is 5. So your answer would be plus or minus square root of 7 over 5. Okay. Awesome. All right, and last one here. First of all, we would add over the 16. So notice all of these steps are pretty similar to start out. So that would be 5x squared equals 16. I'm going to divide by 5 to get that x squared by itself. And I'm left with x squared equals 16 over 5. So then I go ahead and I take the square root. And again, that's like taking the square root of the top and the square root of the bottom separately. So square root of x squared is x. Square root of 16 is going to be 4. But square root of 5 is just like the 7. It's just going to be left as square root of 5. Now, here's the thing. We cannot just leave this one. It cannot be our final answer because we have this square root in the denominator, which is mathematically illegal, right? So what we're going to do is, we're going to rationalize this. And in order to do that, we are going to multiply both the top and the bottom by square root of 5. Okay, so when I do that, we're going to be left with x equals plus or minus 4 times square root 5 is just going to be 4 root 5. And then on the bottom, square root of 5 times square root of 5 is 5. So now we've rationalized it so that there is no longer a radical in the denominator, and we are good to go. Okay. So as you can see, I purposely made it so these got a little bit harder as we went. But those are really the only types of problems that you'll see for now, okay? All right, so if you want to do more practice, you are more than welcome to. And you could go ahead and pause the video here if you'd like, okay? But there's one other type of problem that I would like to talk about, and that might be these examples here where it's not just an x squared, but it's a binomial in parentheses squared, okay? So your steps are going to be similar. You're still going to want to isolate whatever it is that's squared. So in this case, the binomial that is squared, you want to isolate that. Okay, so in order to do that, step 1, they add 5 to both sides so that it's just the x minus 3 squared equals 25. And then to get rid of the squared right away, they take the square root of both sides. And then here's where we're going to get 2 answers, because when we take the square root, we get plus or minus 5, right? So then we need to set, so that was step 3, simplifying. But then you need to make 2 equations, and one needs to be set equal to the plus 5, and one needs to be set equal to the minus 5. And then you go ahead and solve for x in step 5. Okay, so here they added the 3 to the 5 to get 8. And here they added the 3 to the negative 5 to get negative 2. Okay, so let's try 2 of those real quick. So in this first one, I need to isolate the x plus 5 squared. So in order to do that, I'm going to divide by this 2 out front. So I get x plus 5 squared equals 32 divided by 2, which is going to be 16. Okay, so now I've isolated that. So now I'm going to take the square root of both sides to get rid of that squared. And so that's what's nice is this will cancel the square root and the squared. So you'll be left with x plus 5 on this side. And you'll be left with square root of 16 is plus or minus 4. So then, like I said, we've got to separate this into 2 equations. X plus 5 equals the positive 4, and x plus 5 equals the negative 4. Then you're just solving for x, so I would subtract 5 over and get x equals negative 1. And I would subtract 5 over and get x equals negative 9. And that's it. There's your answer. Okay. All right. And last one here. Let's go ahead and solve this one. So we need to isolate this here. So I would first add the 25 over. And that's going to leave me with 4 times x plus 1 squared equals 25. Then I'm going to divide by the 4 that's out front. And again, I can tell that 25 and 4 are both perfect squares, so I'm going to leave that as is. Because in my next step, I'm going to want to take the square root. Okay, so that's what I'm going to do here. I'm going to take the square root of both sides. And this is going to leave me, again, this will cancel with this. So that will leave me with just x plus 1. And then on this side, it'll be plus or minus square root of 25 is 5. And square root of 4 is 2. Okay, so if you want here, we know that 5 halves, or 5 divided by 2, is equivalent to 2.5, or 2.5. So let's go ahead and just write it as that to make it a little bit easier for ourselves. Okay, so now this is where we split it up into 2, and I'm going to write it as x plus 1 equals the positive 2.5, and x plus 1 equals the negative 2.5. So I would subtract 1 over and get x equals 1.5, or in other words, 3 halves if you wanted to write it that way. That's one of your solutions. And then the other one, you're going to subtract 5 over, subtract 1 over, and negative 2.5 minus 1 is going to be negative 3.5, or a negative 7 halves if you wanted to keep it as a fraction. Either way would be totally fine, decimal or fraction. Okay, so that's pretty much it for your solving by square rooting. So if you have any questions, we will be going over it tomorrow during our Zoom. Thanks. Bye-bye.